Thank you, Bjorn. Okay, so why another model-based thing? So why model-based testing and evaluation? Well, I think it's because T&E is in our purview. We should care about it. And it's a natural extension into that realm. So from my experience, the T&E community operates in a largely document-based environment. And by document-based, I mean a multitude of artifacts in various file formats scattered all over the place, all with inherent dependencies on it. This is the system model diagram that we use to sell MBSE to project leaders. It's the same kind of idea. So there's no underlying model to help unify all of that and provide the glue so that T&E stakeholders have a coherent set of views so they can gain information and begin to address their particular concerns. So I think a model-based approach to T&E can help. And why? Well, I think it brings rigor and precision through forcing T&E teams, SE teams, and the subsystem leads to get specific and state precisely what they mean in an unambiguous fashion. It's integrated with the system model, and it gains a lot of the same benefits as MBSE in general: consistent vocabulary, semantically precise definitions, all of those things we've come to love about MBSE, or hate, depending on how you look at it. It can be transparent and analyzable. So this is valuable to project leadership where they know and they can get a comprehensive vision about how the system is going to be integrated and tested over time. It can help with resource scheduling and procurement conflicts through looking at dependencies, critical paths, things like that. It can be used to help with catching design gotchas through rigorous technical definition and test simulation, for instance, and also be used for impact analysis, where you have the case where what happens when component A of subassembly B fails test case Y? What happens? What requirements are not being met in that case? And what does it mean? Does the test have to be redone, repeated? And how does that impact my schedule and my overall cost? It can provide resiliency. So from my experience, again, the only consistent thing on some projects is change, especially with personnel. So having a model, a T&E model, helps provide resiliency through having a single source of truth of project and technical information. That way, new team members can more quickly come up to speed on what's going on. And last, we finally get to see all of our early front-end coal shoveling SE system modeling efforts finally pay off. So we move up the right side of the V into system realization, and we see our baby system model that we've cared for and nurtured over time actually grow up and go into action. So where do we begin? So there are numerous factors to consider when you're talking about test and evaluation. So for instance, why is a test being conducted? How do we know if it's successful? What's being tested? What is it being tested against? What are the requirements? What are the verification criteria? How do we render a verdict? And is pass or fail too restrictive? Do we need other kinds of measures? Do we need margins? What kind of test equipment is needed to properly stimulate the device, the system under test, and record some kind of response from it? What kind of emulators or dummy loads or stubs do you need for integration testing? And when and where will the test be conducted? Who will be conducting the test? And for all of those different kinds of test resources, when are they going to be available? Are they actually available when you need them? How will they be acquired? Who owns them? Where are they coming from? And are they certified for use in the test? So all of these things we care about. We care about how will the test be conducted? What are the specific steps in the test case? What are different kinds of pre and post conditions? Hazards, how do you handle anomalies and deviations from the nominal pass? What are the valid test conditions? And then finally, what data was used to stimulate the test? What was recorded from the test? What was the result of the regression and post-processing that had to occur afterwards? And what was the result of that? Where does the data actually live? What database is all of that information located in? So all of these, when you look at them, they can really be described in terms of the 6 primary interrogatives: who, what, when, where, why, and how. So all of those, when you look at them, again, they fall into 4 bins or aspects. You can conceptualize that in terms of configuration, arbitration, data, and procedure. So configuration is concerned with the setup of the test, specifically the interfaces and how the different the system under test, the different test equipment, the emulators, all of the different kinds of test resources are connected together physically. Arbitration aims to render a verdict on the test, and also, what can we learn, and how does this feed into impact analysis as far as what requirements are met, and how does that affect schedule and so forth. Data, of course, is concerned with the data used in the test, what was used to stimulate the device, what was measured, recorded, and what were the results. And procedure is the behavioral specification of the test. What are the specific actions? What are the interactions between the system under test and the test equipment? Along with other kinds of amplifying information, like what are the pre and post conditions, how are hazards being handled, how are anomalies and deviations being handled, and so forth. So all of these elements, when you put them all together and begin to assemble them, they form the basis of a test architecture. And execution and evaluation of that architecture is very useful. You can learn a lot about it, yeah, I lost my train of thought there. Simply an instance of the test architecture is when you actually execute and evaluate it. So oftentimes when I am tasked with applying MBSE to a particular problem or model-based approaches to a particular problem, I first look at the software community to see, well, are the software guys actually looking into this, and have they already started thinking about this? And sure enough, they have. So one of the more notable approaches is by an author named Paul Baker in his book, Model-Driven Testing Using the UML Testing Profile. It was originally developed for software, but it can be extended to systems and large-scale T&E. So the formal description of the T&E domain uses SysML as the foundation, with concepts borrowed from the UML for testing profile and extended as needed. So now with the language in place, we can begin to start talking about what is a test architecture. So generically speaking, a test and evaluation event has many test contexts, each of which contain a base test configuration context, enumerating the different kinds of test resources. Anytime there's a new test configuration or a new suite of test cases, you need a different kind of test case or test context for the test and evaluation event. So the UTP defines a test context as simply a container for test cases, test control, and the test configuration. Well, when you look at it, when you look at the block there in the middle of the test context block, there's no externally visible relationship between what verdict for a particular, or what verdict goes with a particular test case. Also, there's no real relationship between what data goes with a particular test case either. So this can quickly become confusing, especially if you have a lot of different test cases with a lot of different kinds of verification criteria. So I extend the basic concept where I include 2 additional contexts. One is the test case context and the test configuration context. The test configuration context simply just enumerates all the different kinds of equipment, the system under test, emulators that go into the physical setup of the test, as well as defining and describing what the interfaces and connections between them are. And then the test case context is a contextual wrapper for a specific test case, with that, you're able to have a specific verdict for a test case, as well as capturing specific data that was used for a given test case. So as you can see there, a test case refines the test objective, which declares the intent of the test, and also verifies a requirement or a set of requirements. So what is a test configuration? A little more about that. Well, it inherits from the system in use context, which enumerates all the actors that communicate with the system. And this is important in determining what interfaces the system in use, the system we're looking at, has to have in order to realize the expected behavior. Through property redefinition, you're able to set the specific role types of the actors to the specific resources that you're using in the test, as well as set any actors that are inconsequential to the test to zero, their multiplicities to zero. Any test interfaces that you define, they have to, through inheritance there, they have to conform to the original specification or some subset or subtype of the original specification in order to maintain interface control. Next, regarding a reconfigurable system under test, the UML for test profile doesn't give any kind of guidance or any kind of concepts to help handle multiple versions or configurations of a system under test, which reflects the various development stages and integration stages of the system over time. So you can use SysML-bound references to help with that. They actually work quite nicely for that. Here, we're able to substitute specific components and assemblies or sub-assemblies with the actual components, whether they're breadboard or brassboard versions or prototypes or sub-assemblies, whatever, in the place of those as-designed components and sub-assemblies. Now on test resources. So the UML for testing profile does go into detail about what a system under test is, as well as what a test component is. A test component is something that just stimulates a system under test and or measures and records data from it. But when we're talking about testing and evaluation, that's not enough. We need more base types, specifically a base test facility, a test support item, which is like an emulator or a stub or a dummy load, and also test personnel. And all of those inherit from the basic test or the base test resource. And you can use all of that information to aid in resource utilization. So on resource utilization, that's characterized as the relationship, which is I show as an association block, between a base test configuration context, which enumerates all of the basic resource types, and the test resource. And the resource utilization is characterized by an availability Boolean. Is it available or not? Well, how do you begin to calculate that availability? One thing to look at is in terms of acquisition. Acquisition in this regard, I characterize that as the relationship between the resource utilization for proper context and the owning organization. The acquisition of a resource itself is characterized in terms of when is it actually available to be used in that context, what is the utilization cost, and what is the acquisition method, such as is it going to be acquired through rental or procurement. Next, you can also look at certification to help with determining availability. So that's established as the relationship between the certifying organization and a test resource. And we care about certification because whether it's for safety reasons, network security concerns, or simply being able to trust a measurement, many test equipment have to carry some sort of certification in order to be able to be used for a test, and that can impact your resource availability. So test resource certification is characterized in terms of when was the issue, or when was the certificate issued, and when does it expire. So considering that along with those dates, along with the dates in the resource acquisition block, you can compare both of those, or all of those, against the scheduled test date to see if the resource is actually available when you need it. If not, this can gain insight into resource scheduling and potential procurement conflicts. So moving on now to talk about the test case context, we first start talking about, am I good or? Okay, all right, I'll speed on through. All right, so how do we bind data to test interfaces? Well, the UML for testing profile, as well as Baker's approach, is really geared towards software, and most software components are described in terms of provided and required interfaces. Well, what if those interfaces aren't described in that way? How do you bind data for a particular test case to a test interface? This is an approach. This is an approach that could work. Here we have a data pool, which is a container for data, which has the stimulus data that you want to be able to feed into, in this case, some kind of operator emulator test interface. So we're binding stimulus data to that operator trigger. Also, we care about response data. The UTP, UML for testing profile, doesn't really go into detail about response data. So here, I show, maintenance data using a maintenance interface for data recording gets fed into this response data idea. And we care about that because we can use that response data to check against performance and non-functional requirements. And also, a lot of this can be a mountain of data, which obviously doesn't need to live in your SysML model, but we can use tags and external references to be able to link to those particular files. Okay, test procedure, not a lot of new information there, but I will say that it's important that those procedures be specified in a way that's executable. That provides invaluable insight into predicting test behavior before the test actually occurs, and potential cost savings there through not having to go and repeat test. Finally, test case arbitration. This is where we begin to arbitrate the test after it actually executes. Here we have the idea of a resultant data. This is when regression analysis and post-processing has to happen after the fact, and we get some kind of result back. That result is compared against the actual required value, or the required value rather, to yield some kind of Boolean, true or false. The test arbiter takes that, it compares it against what was actual, what was required, what were the valid arbitration conditions. That's important too when we're talking about testing and evaluation. Valid arbitration conditions such as what were the minimum and maximum valid atmospheric environments, for instance. There may be other kinds of valid arbitration conditions. So the test arbiter considers all of those and renders a verdict. Well, in some cases, a pass or fail verdict is insufficient. We want to get some kind of margin. In the cases where maybe the system under test failed that particular test case only by a small margin. Well, what does that mean? Do we necessarily have to repeat the test? Maybe not. So all of that is a lot of information, but it doesn't have to be captured all at once. It can be added in over time depending on the specific needs of your project. But I would say that sooner is better than later in this case. So in summary, my goal here was not to bash Paul Baker and his approach in the book, nor was it to bash the UTP. I think the software community has laid a good foundation for us. My aim is simply to extend those concepts towards test and evaluation of systems, including software, through leveraging the UTP and SysML. And my goal, or my hope, is that this work resonates and is valuable to the T&E community. Thanks.